Emergency response crews face two primary challenges when entering dangerous environments. Is the air acceptable for normal, unprotected breathing? And, is the air safe from potential explosions? Portable gas detection equipment can help emergency response crews meet these challenges. Gas detection needs are expanding. Fire departments increasingly respond to situations where hazardous substances may be present, and proper detection equipment is necessary. A critical aspect of proficiently operating a gas detector is understanding how it works. The more you know about and use it, the safer crews and the public will be. This video will cover the MSA Altair 5X Multigas Detector's operation, and how to use it in 4 response scenarios. The following demonstration for the Altair 5X will happen in real time, demonstrating the actual time required for device startup. The Altair 5X gas detector uses a one-button operation. To turn the unit on, perform the following steps. Briefly press the on-off button to switch the instrument on. Once turned on, the unit will display the startup logo, and perform a self-test and sensor warm-up. During the self-test, the instrument checks alarms and installed sensors. The instrument will display the software version, device serial number, company name, department, and usernames. Next, the unit must perform a flow test. Block the pump inlet when the display reads Pump Test, Block Sampling System. The pump inlet is located on the back of the device. To block it, place your finger over the pump inlet. You will have 30 seconds to block the pump once the flow test is triggered. The unit will beep and display Pump Test Pass, indicating the pump test was successful. After the pump test, the startup sequence will resume and the unit will display the following: the combustible gas type and installed sensor indication. The alarm set point for the low alarm. The alarm set point for the high alarm. The alarm set point for the short-term exposure limit. The alarm set point for the workplace exposure limit. The calibration cylinder settings. The current date. The date of the last calibration. And finally, the unit enters a sensor warm-up period. When the fresh air setup display is flashing, perform the setup. You will have 10 seconds to activate the setup. To perform the fresh air setup, press the down arrow button briefly. Do not activate the fresh air setup unless you are confident you are in fresh, uncontaminated air. Otherwise, inaccurate readings can occur, which can falsely indicate that a hazardous atmosphere is safe. If you have any doubts as to the quality of the surrounding air, do not use the fresh air setup feature. To bypass the fresh air setup, press the up arrow or wait 10 seconds. Failure to follow this warning can result in serious personal injury or death. The unit is now ready for air monitoring. To turn the unit off, press and hold the on-off button. The device displays a progress bar, which shows how much longer to hold the button down. When the progress bar is complete, release the button, and the Altair 5X will shut down. In this segment, we'll cover the air monitoring procedures during overhaul operations. Even after extinguishing the primary fire, firefighters still face many hazards in overhaul operations. However, the greatest danger is an invisible hazard that is mostly ignored. The atmosphere is often as toxic, if not more so than during the fire's active burning phases. Firefighters know they can't survive if they breathe in superheated air or toxic gases released by the fire. However, they often forget that the fire's heated fuels are still releasing toxic gases during overhaul. Hazardous gases exist in a structure after a fire, and many of them are undetectable without monitors. In this scenario, we'll monitor oxygen, carbon monoxide, and hydrogen cyanide. But before covering the scenario, we'll first review the gases we'll be monitoring. Next, we'll review the hazard summary for oxygen. It can also be represented with the molecular formula of O2. 20.9% is the oxygen safe level. We'll come back to this number in a moment. If the reading is greater than 23.5%, it means the atmosphere is oxygen enriched. Elevated concentrations of oxygen can cause ordinary combustible materials to become flammable or explosive. Sources of oxygen enrichment are most common in medical, industrial, or welding businesses that use pressurized oxygen, cryogenic gases, liquid oxygen, oxygen vents, and other oxygen sources that can increase oxygen levels. Oxygen levels at 19.5% or lower are considered an immediate danger to life and health. The acceptable oxygen levels in an ambient environment are between 19.5% on the low side and 23.5% on the high side. When we think of the oxygen level on a gas detector, think of the number 20.9%. If this moves in either direction, start thinking about what might be displacing or increasing the oxygen level. Next, we'll review the hazard summary for carbon monoxide. This substance can also be represented with the molecular formula of CO. When carbon monoxide levels are at 35 parts per million or greater, firefighters must don self-contained breathing apparatus. Firefighters can expect all fire-involved environments to contain high carbon monoxide levels, with levels substantially elevated during the overhaul phase. When not wearing SCBA, there is an even greater chance of carbon monoxide poisoning during overhaul due to the physical exertion. Carbon monoxide is the leading cause of accidental poisoning deaths in America. This odorless, tasteless, and colorless gas is known as the silent killer. Early CO poisoning symptoms such as headaches, nausea, and fatigue are often mistaken for the flu. Prolonged exposure can lead to brain damage and even death. For quick reference, at 35 parts per million or greater, the detector will alarm, and firefighters must don self-contained breathing apparatus. Next, we'll review the hazard summary for hydrogen cyanide. This substance can also be represented with the molecular formula of HCN. A reading of 4.5 parts per million, or greater, requires full personal protective equipment and self-contained breathing apparatus. Hydrogen cyanide is an exceedingly poisonous gas. It may also be the deadliest combustion product, and the one firefighters should be concerned with above all others when fighting fires. For this reason, it's frequently referred to as the firefighter killer. It is commonly present in an overhaul environment. HCN is produced by incomplete combustion of natural fibers, like wool and silk, and synthetic polymers, including polyurethane and nylon, which are widely used in insulation, cushioning, carpets, building materials, and home furnishings, like mattresses, pillows, and bedding materials. The device's average response time for carbon monoxide is 10 seconds, whereas hydrogen cyanide is 30 seconds. Remain stationary for a minimum of 30 seconds, to allow the gas detector adequate time to monitor the air for the presence of hydrogen cyanide. Let's review the three gases most commonly present during salvage and overhaul operations. 20.9% is the oxygen safe level. An oxygen reading below 19.5% or above 23.5% will require the use of SCBA. When levels move below or above 20.9%, look for sources displacing or increasing the oxygen level. If carbon monoxide levels are 35 parts per million or greater, the detector will alarm, and firefighters must don SCBA. If hydrogen cyanide levels are 4.5 parts per million, or greater, it requires full personal protective equipment and self-contained breathing apparatus. Now we'll cover the air monitoring procedures during overhaul operations. Let's take a look at an overhaul scenario. Before entering the structure, perform the startup and fresh air setup procedures demonstrated earlier in this video. Remember, do not activate the fresh air setup, unless you are confident you are in fresh, uncontaminated air. The fresh air setup can be done inside the cab of the fire truck. Wearing your SCBA, enter the structure when all fires are extinguished, with only light smoke inside, and positive pressure ventilation is in place to assist in removing toxic smoke and other fire gases. Positive pressure ventilation assists in the venting of smoke and high temperature combustion products. The positive pressure ventilation unit in this scenario is electric. Firefighters choose electric fans because of the concern of carbon monoxide emissions produced by gas fans. By using an electric fan, there are no added exhaust fumes associated with internal combustion engines. The electric fan will also add cooler, cleaner air during the overhaul and investigation process than the gas unit, with less noise. Conduct an initial reading throughout the structure to understand the overall atmospheric quality. And identify areas that require additional ventilation, to bring air quality to safe levels. Once the initial scan is complete, attach the gas detector to turnout gear for continuous passive monitoring. Remember that the atmosphere during salvage and overhaul operations is dynamic. It is continuously changing. Opening walls, ceilings, voids, and partitions to check for fire extension can rapidly change the air quality. Having the unit attached to turnout gear will continuously monitor air quality until salvage and overhaul operations are complete. If the unit alarms during overhaul operations, be prepared to don self-contained breathing apparatus until the area again reaches a safe level. Here are a couple of crucial points to remember during salvage and overhaul operations. Once the air is at safe levels, you may remove SCBA. However, other toxic and carcinogenic hazards may be present that are not tested by the Multigas Detector. Also note that N95 masks provide zero protection against poisonous gases. Your SCBA is your best source of protection during overhaul procedures. Firefighters should wear the gas detector to continue to monitor the air quality throughout salvage and overhaul operations. If the detector alarms and you are not wearing SCBA, re-don SCBA and assess the situation for additional positive pressure ventilation requirements. In this scenario, we'll cover the air monitoring procedures during a response to a chlorine incident involving a railcar. Chlorine is a common hazardous material, found in most communities in the United States, as gas, or compound with other chemicals, that can release chlorine when in contact with water, or other chemicals. It is generally transported and stored as a liquefied compressed gas, and found in 100 to 150 pound cylinders, 1-ton containers, and railroad cars. Before we cover the scenario, we'll review the hazard summary for chlorine. It can also be represented with the molecular formula of CI. The gas detector will alarm at 0.5 parts per million. Response to chlorine incidents requires the use of self-contained breathing apparatus and a Level A protective suit. Level A protection should be used until monitoring results confirm the chlorine leak has been fully contained. Chlorine is classified as immediately dangerous to life and health. Chlorine is toxic by inhalation at 1 part per million, and after a few breaths at 1,000 parts per million, chlorine can be fatal. Chlorine liquid can irritate or burn the skin and cause burning pain, inflammation, and blisters. Chlorine gas is poisonous, irritates the mucous membranes, and exposure can lead to chronic and even fatal illness. It is a potent oxidizing agent, and can react explosively, or form explosive compounds with many common substances. It is non-flammable and a strong oxidizer. Because chlorine is a strong oxidizer, it will support combustion even though it is non-flammable. The agent may ignite combustibles, like wood, paper, oil, and clothing. Fire will produce irritating, corrosive, and/or toxic gases. It is important to note that chlorine is heavier than air and may collect in low-lying areas. This scenario will cover response to a chlorine incident involving a railcar and how to use the gas detector to set up hazard zones, assess cloud dispersal, provide continuous monitoring of the cold and hot zones, and post-work assessment. An essential element of any hazardous substance release site is the establishment of safety zones. A recon crew wearing turnout gear and self-contained breathing apparatus will first use the gas detector to establish the hot zone. The exclusion zone, or hot zone, is the area with contamination and the highest potential for exposure to hazardous substances. The recon crew will drop a cone at the first activation of the meter, which will alarm at 0.5 parts per million. This first cone will mark the beginning of the hot zone. First responders entering the hot zone require a Level A, fully encapsulating suit with self-contained breathing apparatus. Outward from the hot zone is the warm zone. The warm zone is the area around the hot zone and is typically used for decontamination. The cold zone is the area of the site that is free from contamination, and that may be safely used as a planning and staging area. Wind can extend hazardous conditions beyond the initial incident site. Continuous monitoring of wind direction is critical to evaluate the possibility of toxic substance levels reaching people, businesses, and critical facilities. Incident teams should determine wind direction to extend the exclusion zone, possibly crossing into the warm zone, cold zone, and beyond. Station a gas detector at the hot zone, and in the cold zone, downwind from the incident site, to continuously monitor chlorine levels. If wind or other conditions are carrying the chlorine cloud outside the hot zone, the exclusion zone should be extended and perpetually monitored. A chlorine incident poses a significant threat to human health and safety, the safety of first responders, campus property, and the surrounding environment. It is critical to monitor wind direction continuously and reposition the hot and cold zone detectors to each zone's downwind side as conditions change. It is also imperative to notify the incident commander and emergency responders of initial and changing zone conditions throughout the incident. After controlling the leak, use the gas detector to determine the mitigation measures' effectiveness in stopping the leak. If the unit alarms, the leak has not been contained. Make containment adjustments until the gas detector no longer alarms.
2400 for each personnel. Did find a leak and relief valve. Moving to the rehab area at this time.
Emergency response teams perform services or rescues in confined spaces. While often industrial, a confined space is typically defined as any enclosed area not meant for human habitation, such as a sewer or storm drain. The nature of confined spaces can cause toxic vapors to become highly toxic and harmful, and are automatically classified as immediately dangerous to life and health, requiring adequate precautions. The Multigas Detector can help identify whether a confined space atmosphere is safe, or responders need self-contained breathing apparatus before entry. The confined space scenario will demonstrate the proper procedure for using the Multigas Detector to determine entry precautions for confined space entry. The method will also demonstrate vertical air sampling using an air sampling probe and a 10-foot line. The probe and line accessory allows for vertical drop air sampling up to 11 feet. Attach the probe to the pump inlet located on the back of the gas detector. Then connect the probe to the line accessory. After attaching the probe, secure the line and probe to a pike pole with hook. Attach the tip of the probe about an inch below the pike pole's handle to protect the probe tip when lowering into a confined space. The hook will allow hands-free, continuous air monitoring near the bottom of the confined space. A scribe will accompany the responder with the Multigas Detector and record the following: the start time and air level at the start of monitoring, air quality reading at each level, top, middle and bottom, continuous air monitoring at 5-minute increments, and the time of entry into the confined space. For this scenario, the probe is lowered and paused for a minimum of 30 seconds at each depth to monitor air quality at the top, middle, and bottom of the confined space. Measure the top sample around the 2-foot depth. Measure the middle section from a 5-foot depth. Finally, capture the ground sample at 1 foot from the bottom, where you can rest the probe on the person at the bottom of the confined space. Poor ventilation leads to insufficient airflow, which can increase hazardous conditions. There could be a considerable lack of oxygen, exposure to harmful fumes and gases, or the presence of ignitable or combustible particles in the atmosphere. A confined space blower can force the contaminated or poor air out and draw in the fresh air, creating proper ventilation and airflow. The detector has 4 gas detection, including oxygen, carbon monoxide, hydrogen sulfide and methane. It is equipped with a catalytic combustible sensor that detects various combustible gases, up to 100% lower exposure limit, or LEL. If the unit alarms for combustible gases, leave the area immediately. Remaining in the area under such circumstances can cause serious personal injury or death. Here's an overview of using the gas detector during confined space entry. Use the probe and line accessory for vertical drop air sampling. Sample the air at the top, middle, and bottom of the space for a minimum of 30 seconds at each level. Have a scribe record the following: the start time and air level at the start of monitoring, the air quality reading at each level, top, middle, and bottom. Record air quality at 5-minute increments. And finally, the time of entry into the confined space. If the multigas detector identifies unsafe air quality levels, use adequate precautions before entry, such as self-contained breathing apparatus. If at any time the unit alarms for combustible gases, leave the area immediately. Carbon monoxide is one of the most routine hazmat calls that fire departments run today. Whether it's a residential CO alarm for a furnace failure, a car, or a piece of equipment running in a building, the public expects trained and qualified responders to assist them. CO is a colorless, odorless, and toxic gas. It also has flammable properties when it approaches 125,000 parts per million, or 125,000 ppm. Damaged or faulty natural gas or propane appliances, such as gas stoves, furnaces, and dryers in the home, can produce excess amounts of carbon monoxide. A carbon monoxide detector is your best protection from the dangers of CO poisoning. When arriving on scene, contact the occupant and get all pertinent information by asking the following questions. What types of appliances utilize natural or propane gas? Was any work done on them lately, and is this an ongoing problem? Firefighters should be wearing self-contained breathing apparatus, which may be necessary if the gas detector alarms. Approach the entrance and begin utilizing the gas monitor to scan for carbon monoxide. The device's average response time for carbon monoxide is 10 seconds. It's essential to allow the gas detector adequate time to monitor the air for carbon monoxide presence. If CO levels are 35 parts per million or greater, the detector will alarm, and firefighters must fully don SCBA. Even though the resident may have a good idea of where the problem is coming from, it is good to monitor all gas appliances as a courtesy, and for safety. If unable to rapidly assess the faulty appliance, or the levels detected on the gas detector is more than 10% of the lower explosive limit, shut off the meter's external gas supply. Proper ventilation of the structure is another action step for CO response. Just be aware that if the gas meter readings are above the high explosive limit, ventilating will take the air-fuel mixture through the explosive limits before it gets better. Control all sources of ignition. If it is necessary to secure electrical power to a structure, utilize outside breakers. Once the structure has been ventilated sufficiently to allow personnel to enter safely without SCBA, start coordinating diagnosis and isolation tactics with the gas company representatives. The gas company service representative will restore the gas service. Only allow building occupants back into the structure when the gas monitor levels are 0% and the gas company service representative concurs. Chester County Emergency Management Agency provided this program. For future viewing of this program, links are available in the description box below the video that link directly to the detector startup demonstration, and each of the 4 scenarios. Additional training and emergency exercise videos are provided on the Chester County Emergency Management Agency YouTube channel.